Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good day to everyone. Can you hear me?
Yes, doctor.
Okay.
Morning. Yeah.
Okay, how are you? I hope all good.
Good morning, doctor.
Morning. Okay, so let's fill in your attendance first. Wait a minute. Morning. Okay, the attendance in the chat. Please fill in your attendance first. Okay, sorry, forgot to enter. Okay, let me share again for those just join. Okay, the attendance in the chat. Okay, can we start? Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. Okay, so maybe if someone join this, I hope all of you can help me to share the attendance to the newcomers. Okay, so we start. My name is Norazrena Abu Samah. Okay, you can call me Azrina. I'm from School of Education, Educational Technology lecturer. And okay, the topic for today is quantitative data analysis with SPSS. So we will use SPSS. If you have it, you can open it now. Okay, because maybe it takes sometimes. Okay, if you don't have SPSS, you can listen first, and later I will share the recording and you can try later. Okay, so okay, so for statistics, when we deal with statistics, okay, we deal with variables. Okay, there are two types of variables, which are discrete variable and continuous variable. Okay, so for discrete variable, no value can exist between two neighboring categories. Okay, for example, like gender, we have male, female. There is no in between. Okay, but and also like race, in Malaysia we have Malay, Chinese, Indian, and so on. Okay, so there is no in between, so it means there is no value exists between the two neighboring categories. We call that as discrete variable. We must understand our variable first before we do the statistic analysis. Okay, and then number two is continuous variable. Okay, there are infinite number of possible values that fall between any two observed value. Okay, let's say our weight, then maybe 25.550, or maybe for our height 157 point something. Okay, so infinite number. Okay, so that's the difference between discrete and continuous variable. Okay, and then there are four types of measurement scales. Okay, let me show again. We have discrete and continuous. Okay, and then we have measurement scales. Okay, so nominal and ordinal is for discrete variable. Okay, so discrete variable, okay, it's related to nominal scale or ordinal scale. Okay, for nominal scale is an unordered set of categories identified only by name. Okay, just like its name, nominal, so name, just name it. Okay, nominal measurements only permit you to determine whether two individuals are the same or different. Okay, for example, the country, Malaysia, China, Indonesia. So we just name it. That's for nominal scale. Okay, and also for gender, male, female, also nominal scale. So when you do the statistics analysis, you must understand also what is the measurement scales for your variable. Okay, first you have to look on the whether it is discrete or continuous. And then if it is discrete, okay, so you have to find out, is it nominal or ordinal? Okay, and then an ordinal scale is an ordered set of categories. Okay, ordinal measurements tell you the direction of difference between two individuals. For example, is the Likert scale. So please bear in mind that Likert scale is one of ordinal scales, very famous ordinal scale. Okay, because we ordered it. Okay, we order the categories. Okay, so it is ordinal scale. Okay, also our grade is an ordinal scale, which is A, B, C, D, E, and so on. We order it, but the score of it is not an ordinal scale. But when we order it into grade A, grade B, grade C, D, and so on, it is called ordinal scale. Okay, so when we have the variable, we must think first how we collect the data. Okay, so how the data? So from that we can determine the measurement scales for that data. Okay, and then we have interval scale and ratio scale. Both these are for continuous variable. Okay, so for continuous variable, it is infinite, so it is whether interval or ratio. For interval is an ordered series of equal size categories. Okay, interval measurements identify the direction and magnitude of a difference. Okay, the 0 point is located arbitrarily on an interval scale. Okay, it is arbitrary for 0 point. For example, IQ score. Okay, because there is no score of 0 for IQ, so it is interval. But for marks, for your examination marks, okay, there is 0. When there is no at all correct answer, then you will get 0 marks. So that it is ratio scale. Because for ratio scale, the 0 is absolute 0. So 0 is 0. Okay, like that. So like temperature also. Okay, so for Kelvin, okay, Fahrenheit, it is ratio scale, but for Celsius, okay, for degree Celsius, it is interval scale. Okay, because the zero temperature, 0 degree Celsius, it means that it doesn't mean that there is no temperature at all. Okay, it is a freezing point, so it is arbitrary. Okay, like that. So I hope you understand between these 4 types of measurement scales. Okay, so this is how you to determine it. So if the data is alphanumeric, alpha is what word, okay. So if alphanumeric, so you must to ask yourself, is it order? If yes, then it is ordinal. If it is not ordered, then it is nominal. Okay, for totally numeric data, okay, how's the 0? Okay, so if the 0 is arbitrary, then it is an interval. If the 0 is true 0, okay, so it is a ratio. Okay, so I hope this helps. Okay, then in statistics, okay, about the attendance, okay, can you help me, anyone, to share the link for your friends? Okay, so in statistics, uh, okay, so there is we have central tendency. Okay, so in general terms, central tendency is a statistical measure that determines a single value that accurately describes the center of the distribution and represent the entire distribution of scores. Okay, central tendency. So where it is a tendency to go in the middle, the central. Okay, the goal of central tendency is to identify the single value that is the best representative for the entire set of data. Okay, the mean. Okay, the first one is the mean. You know it, right? We call it mean or average. Okay, in statistics we call it mean. Okay, but in our daily life we call it average. Okay, the mean is the most commonly used measure of central tendency. Computation of the mean requires scores that are numerical values measured on an interval scale or ratio scale. Please pay attention on this. Okay, mean can only be calculated for interval scale and ratio scale. Okay, both is under the continuous variable only. You cannot calculate mean for nominal and ordinal scale. It's not valid. Okay, so please remember this. Okay, the mean is for interval scale and ratio scale only. Okay, so conceptually, the mean can also be defined as the mean is the amount that each individual receives when the total sum of x, it is total or sum, okay, sum of x is divided equally among all n individuals. Okay, it's an average. or the mean. Okay, the mean is the balance points of the distribution because the sum of the distance below the mean is exactly equal to the sum of the distance above the mean. Okay, the mean is also called the balance point if, okay, the distance below and above are the same. Okay, we will see later. Okay, when mean becomes inadequate. Okay, like this. Okay, you have one bigger and one smaller, and then you weighing both together, and then you divide into two. Okay, so it is very inadequate. So like that. So okay, so please bear in mind on that. Okay, then the second one is the median. Okay, if the scores in a distribution are listed in order from smallest to largest, the median is defined as the midpoint of the list. Okay, so the midpoint. Okay, when you have, let's say, 11 data, so the middle is the data number 6, right? Okay, if you have 11 data, and then you order it from smallest to largest. Okay, so the data number 6 is in the middle or the midpoint, so it is called the median. Okay, the median divides the scores so that 50% of the scores in the distribution have values that are equal to or less than the median. Okay, computation of the median requires scores that can be placed in rank order, smallest to largest, and are measured on an ordinal, interval, or ratio scale. Okay, for the mean, it is only suitable for interval and ratio. But for median, you can use data in ordinal, interval, and ratio scale. Okay, so for nominal, you can't find the median because you can't order the nominal data. Let's say your name. Okay, it's not suitable. Okay, so then the mode is defined as the most frequently occurring category or score in the distribution. This is for the mode. Okay, the most frequently. Okay, so the highest frequency. Okay, is the mode. In a frequency distribution graph, the mode is the category or score corresponding to the peak or high point of the distribution. The mode can be determined for data measured on any scale of measurement. Okay, this time mode. Mode can be measured in all data. Okay, because we just find the highest frequency, that's all. Okay, so nominal, ordinal, interval, and ratio can find the mode. Okay, but for median is only ordinal, interval, and ratio. But for mean is only suitable for interval and ratio. Okay. Effects of skewness upon relative locations of central tendency. Okay, this is zero skew. Okay, or bell shape or normal data. Okay, normal distribution. The mean is equal to median and is equal to the mode. Okay, for example, if the mean is 10, then the median is also 10, and then the mode is also 10. So this is how the graph looks. Okay, but it will be a positive skew if, okay, the mode is less than the median and the mean. Okay, because the median is always in the middle. Okay, the median is always in the middle between mean and the mode. Okay, so negative skew. Okay, this is the negative skew. The tail, for positive skew, the tail is on the right. For negative skew, the tail is on the left. Okay, so for this one, the mode is larger than the mean. Okay, and the median always in the middle. Okay, then for continuous data or continuous variable, Okay, we can find the mean and then we can find the standard deviation. Okay, measures the standard distance between a score and the mean. Okay, standard deviation measures the standard distance between a score and the mean. So when you get data from the SPSS, you will have the standard deviation. If you understand this, you can explain in your thesis, okay, or in your report. Okay, so what does the standard deviation means? Okay, so standard deviation is actually the standard distance between a score and the mean. Okay, is it positive or is it negative? Is positive, it is to the right, and then is if negative is to the left. Okay, this one. Okay, standard deviation, this is the mean. Okay, so this is the distance. Okay, so this is one standard deviation. It means that this is one standard deviation, two standard deviation, and then multiply three standard deviation. Okay, let's say the standard deviation is 10. Okay, so it means that it is 100 plus 10 is equal to 110. It is for one standard deviation. So you can see how far the data in the population. Okay, so how far it is from the mean. Okay, so this is the summary. Okay, for this one, the statistics. Let's see first. Okay, so in scientific method, there is three type of analysis method, which is qualitative, quantitative, and mixed method. Okay, so mixed method is combining both. Okay, so for quantitative method, there is descriptive statistic and inferential statistic. Okay, for descriptive statistic, you only calculate the central tendency, which is mean, median, and mode. Okay, for variability, you find the range, standard deviation, and variance. Okay, and then for inferential, you run the statistical test. Okay, whether it is parametric or non-parametric. Okay, so if this is for two groups, okay, is there is independent sample t-test and paired sample t-test, okay, or two-way mixed ANOVA, one-way ANOVA, one-way repeated measure ANOVA, and so on. Okay, you can see this one later. Okay, this is for non-parametric. Okay, we will see this one by one later. Okay, to compare two variables. Okay, to compare two variables, if you have to find out the requirements first. Okay, the requirement, if the data is ratio or interval, okay, then you can run the parametric. However, you must check the normality of the other data first. Okay, you have to run the normality test. Okay, if the data is ratio or interval and normal, then you can run the parametric test. However, if the data is ratio or interval but not normal, then you have to run non-parametric test. Okay, this is the requirement. It must be normal. Okay. Also, if the data is ordinal or nominal, you must run non-parametric test. You cannot run the parametric test for ordinal and nominal. Okay. So for parametric test, you will find the mean and standard deviation. Okay. While in non-parametric, you will find the median and interquartile range. Okay, this is what you will write in your thesis. Okay, if you run the parametric test, okay, you must have the data of mean and standard deviation. But if you run the data on non-parametric test involving ordinal and nominal, you must have data on in median or okay, interquartile range. This is can have or not. Okay, but if you have your data is ratio or interval but not normal, you will run non-parametric test, and for that you can have mean and standard deviation and also the median and so on. Okay, to compare for parametric test, to compare one group, okay, to a hypothetical value, it is called one sample t-test. Okay, this is the mean. For non-para is Wilcoxon. To compare two unpaired groups, independent t-test, this one is Mann-Whitney. Okay, compare two paired groups, paired t-test and or Wilcoxon test for non-parametric. Okay, so t-test assumptions, measurement scales. Okay, still remember measurement scales. What are the four measurement scales? Anyone can answer? Still remember what are the four measurement scales?
Nominal,
Ordinal,
ordinal, interval, and ratio.
Good, very good. Okay, nominal, ordinal, interval, and ratio. But t-test is for parametric test. So it is only suitable for continuous data. So what is the measurement scales for t-test? Only two measurement scales for t-test. What are they? Anyone? Ratio? Okay, and interval. Yes, correct. Ratio and interval only. Okay, then you see that it is, for example, it is a ratio data. For example, the examination marks. Okay, it is ratio data. Then you must check the normality. Okay, is it normal or not? If it is normal, then you can also check the homogeneity of variance. Okay, so if it's fulfill all these assumptions, and then you can run the t-test, or else you have to run the parametric test of this test. Okay, the name is this one, whether Wilcoxon, Mann-Whitney, or so Wilcoxon. Okay, so this one no need to remember because it already has in SPSS. Okay, so this is how to calculate the effect size. Effect size is the size of effect. How big is the effect? Okay, is it small effect, medium effect, or large effect? Okay, you can find the R squared and the R value. Okay, T value and the DF is for standard deviation. Okay, sorry, degree of freedom. So the degree of freedom value is in the SPSS result. Okay, so you can find all this result and then you calculate yourself. Okay, and then if you want to use the Cohen's d formula, this is the formula: mean difference minus standard over standard deviation. Okay, so this is how you interpret the result. If the result is below than 0.09, so it is small effect. If below than 0.25 or 0.09 until less than 0.25, then it is medium. Okay, and then large effect. Okay, so then you have when you want to compare more than two variables, okay, 3, 4, 5, and so on. Okay, this is the statistical test for that. Okay, same. Parametric are same. Okay, must for only for ratio or interval and normal. If not normal, you must run the non-parametric test. Okay. So this is the name one-way independent ANOVA, and the non-para is Kruskal-Wallis. And then for parametric, to compare 3 or more match groups, okay, is repeated measures ANOVA. This one is Friedman test. Okay, for example, for this, you want to compare 3 or more unmatched group. For example, you want to compare the result, the examination result for race, or you have 3 classes. Okay, 3 classes. So class A, class B, and class C. So all 3 class has different characteristic. Okay, so 3 different class. So you have to compare using this one. Okay, compare 3 or more unmatched groups. But for this one, for example, you want to test the same students more than twice. Okay, so for example, you have test 1, test 2, test 3, test 4. So you want to compare, is there any improvement between test 1, 2, 3, 4 for the same person? So this is the test you should do. Okay. So the assumptions for ANOVA for parametric are the same. Measurement scale must only ratio or interval. It must be normal and must be homogeneous. Okay. And then this is how to calculate the effect size. All value is in the SPSS table. You can calculate it yourself. Okay. So then for correlation, correlation is to identify the association or the relationship. Okay. Normally we only use the Pearson and Spearman, but you can maybe next time try these 3. Okay. So to quantify association between continuous variables and normally distributed, okay, this means it is for parametric. This is parametric test. Okay, so you want to compare between 2, 3, 4 variables. Okay, but make sure all variables are continuous. It means whether it is ordinal or ratio. Ratio or interval. Okay, whether it is ratio or interval, it means it is continuous variables and normally distributed. If one of the variable is not normally distributed, you cannot run the Pearson correlation. It is wrong. Okay. So please bear in mind for that. Okay. If you have, let's say you want to find the relationship between what is it? Okay, test lah. Okay, we use the test. Okay, because the test is continuous data. Okay, test 1, test 2, test 3, test 4. Okay, we want to find the relationship between the data in test 1, test 2, test 3, and test 4. We have 4 data. Okay, so when we want to compare all these 4, we must run the normality first for all this data. Okay, each of them must be normal, then we can run the Pearson. If let's say test 1 is not normal, but the rest is normal, we cannot run the Pearson correlation. Okay, so if one of the variable is not normal, we must run the Spearman correlation even though the data is continuous, just like the previous one. Okay, so this is for parametric. This is for non-parametric. But if the continuous data is not normal, you cannot run the parametric Pearson. So you have to run the non-para, which is Spearman correlation. Okay, I hope you understand for this. And also, since this is for non-para, so this also applicable for ordinal and nominal data. Okay, I hope you understand on this. And then quantify association or relationship or correlation between one normally distributed continuous variable. Read carefully. Okay. One variable is normally distributed continuous variable and another one in one dichotomous data. There is two variables you want to compare. One is continuous variable and normal. Okay, one is dichotomous data. Okay, like its name is di. Okay, so di is for two. Okay, so dichotomous data, for example, is gender, but gender is depends on how you collect the data. If the data for your gender is only male and female, then it becomes dichotomous. Okay. You understand what I mean, right? Okay, if your data is only has male and female, then it becomes dichotomous data. Only two options. Or the option is yes, no. Okay, then it has two options, yes, no. Or maybe you have, sometimes you have smile and sad. You use for what, for kids you use the smiley, and for sad face then you have two option. Then it became dichotomous data. Okay, so you can use the point by serial correlation. Okay, let's say you want to find the correlation between one normally distributed continuous data. Let's say you want to use their final examination. Okay, final examination. So you must make sure the data for your the final examination is normal. Okay, and then you want to compare between male and female. So you can use the point by serial correlation. Okay. And then to quantify association between two categorical dichotomous data or between two categorical variables. Okay, for these two, this is related. Okay, for these two, this is for categorical data, categorical variables. Okay, for it's maybe ordinal, ordinal and nominal. Okay, so it's also called discrete data. Okay, categorical data or discrete data. So you can, for these two, first you will run the chi-square test. Okay, to identify the correlation, you will run the chi-square test, and then to determine the strength of the correlation, okay, you use the phi or Cramus. Okay, phi or Cramus. It depends. If you are finding the correlation between two categorical dichotomous data, for example, it is like 2 by 2. Okay, the first one is yes, no, maybe. The variable is about, the data is yes, no. And then the second one, male, female. So 2 by 2, you can use phi. Okay, for Cramus, it is two categorical variables. So it, no, for more than two, let's say 3 by 3. Okay, for the race, Malay, Indian, Chinese. Okay, and 3, maybe agree, neither, disagree. So 3 by 3. Or 2 by 3. Yes, no, and the race. You have 3 races. Okay, 2 by 3. Okay, but if 2 by 2, you must use phi correlation. Okay, if more than 2, you use Cramus. But no worries about this. Both in the same result. So the result, you will get the result for both, but you have to choose wisely. Okay. So the correlation you will determine in terms of form. Normally we use the linear form. Okay.
Assalamualaikum.
Waalaikumsalam. Yes?
Please, I have a question, ma.
Oh, yeah.
Yeah, this is what is the matrix correlation?
Pardon?
Matrix correlation, matrix.
Metric.
Yes.
Okay, the matrix correlation. So are
Yes.
you doing that correlation?
Yeah.
Okay, for matrix correlation is almost like cross steps, right? What is your data? What is the data that you use for that one?
I want to test the experience of the teacher to see the relationship between the impact of teacher experience and to the student performance. So am I going to apply the matrix correlation or which correlation?
You want to run the matrix correlation, but it
Yes.
is not. It's not in a SPSS, is it? Are you using SPSS for that? I think it is just like the Pearson correlation, just like the Pearson correlation, because when we run the Pearson correlation, we will have the matrix of the correlation.
Thank
Okay?
you, ma.
Okay, we will see later. Because when you run a correlation, you will have the matrix of that. Okay, the correlation matrix, we call it. Okay, so we will see that later. Okay, even for correlation, there is this is the example of 5 different correlation, but so you must depends on what is your variable. Okay, so let's see first on this. We will see the SPSS later. Okay, so and for correlation, okay, the form linear. Okay, we all normally use linear or non-linear. Okay, and then the directions. Okay, is it positive or negative? So you know, right? The positive correlation. Can you mute my no? Minus. Okay. So for the direction, it's either positive or negative. Okay. So we will see later. Then the degree. Okay. So is it strong? Okay. Weak. Okay. In the middle. Okay. So we will see also on this. Okay. And then regression. Okay, regression is related to correlation. Okay, the regression is finding the straight line equation. Okay, so you are finding the straight line equation. Let's say the y is the anyone talking? Mayin Long, do you want to ask anything? Okay, so for regression, okay, y is for dependent variables, okay, and then x the independent variables. Okay, let's say you want to see whether test has an effect on final exam. Okay, let's say for that. Okay, so if you have the linear equation, you can just calculate it and you will get the estimated value for that. Okay, so this is the data. Okay, this is for example is your data test and final exam. Okay, so this is the plot of your data. Okay, this is the regression line. Okay, the distance or standard error distance between the regression and the data is called the standard error of measures. Okay. Wait. Okay. So next we have chi-square test. Okay, there is two chi-square test for independence to determine whether two variables were independent. This is also to find the relationship. Okay, or correlation or association. So this chi-square is related also to Phi and Kramer. Okay, and then chi-square goodness of fit to compare the observed sample distribution with the expected probability distribution. Okay. Normally, we use the goodness of fit to identify is there any preference in the population. Okay. So let's say there is house. Okay, there is for our null hypothesis we say that all people has same all house has the same preferences. Okay, let's say we have 4 houses. Okay, 4 type of houses. So 25% people will like the first house, 25%, second house, 25%, third house, and 25% the fourth house. Okay, so from this we will see is it the same or maybe there is one house that more preferred than other. So this is to the chi-square goodness of fit. Okay, use this test. Okay, so this is for the extra resources. Okay, so please, you can scan here or go to this URL to get this PowerPoint or these notes. You will get the PDF version. And please click on this link. We will use this. Okay, I wait for you. I wait 5 minutes for you. Okay, this is the code.
It's not going. It's not going.
Pardon? Pardon?
It's not moving.
It's not what?
It's not moving. It's not moving.
Moving?
Slide tu tak bergerak.
Oh, slide tak bergerak.
Dia cakap, it's not moving.
Ni dapat tak nampak? Extra resources.
Yes, nampak.
Okay. Tak tahu kenapa dia tak bergerak tiba-tiba. Okay, so download this PowerPoint first or go to this URL. Okay, please download these 4 files. I'll wait till 10:50.
Doctor,
Yes.
could you please share with us the link? Because we
This is-
cannot, it's impossible for us to scan the QR code and
No, you can write it. Short url.at/ejduw.
Okay, got it. Thank you.
Okay.
Got it. Thank you. And doctor,
Yes.
I have one more question.
Yes.
I'm wondering when we do research design, if we have some questions about how to analyze those questions, who can we refer to if we need some help?
Your supervisor.
If a supervisor may not be able to help us, because my supervisor is doing qualitative research.
Qualitative. Okay.
Yeah.
So you are doing the quantitative.
Yes.
Okay, you can contact me. No worries.
Okay, thank you. So may I ask how can I get in
Okay,
touch with you?
so I give you the link in what? Sorry, in chat for my
Okay,
WhatsApp.
okay. So how about check with? Okay.
Okay, I will share. Wait a minute.
Okay.
So I can go to my WhatsApp.
Hello, doctor.
Yes.
When I scan the QR code, it says the page cannot be accessed now.
Oh,
We cannot download it.
okay. How about the rest? Can you download it?
Yes, we can. Maybe you should use VPN if you come from China.
Yeah.
Because
VPN
they are
is
photographs.
open. Yeah, it's already open, but still cannot download it.
Okay, wait a
You
minute.
can download the slides provided by the professor, and then you can click the links on the slide. They are accessible. You can have a try. It works for me.
Okay,
Okay.
thank you very much for your help.
Thank you.
Assalamu alaikum.
Waalaikumsalam.
I have sent the link for them in our group. They can click there, they will find the PDF.
Yeah, okay, thank you very much for your help.
Okay.
Okay, wait a minute. Okay, I'll share my WhatsApp link. You can just click on it. Wait, where is check. Okay, this is my WhatsApp link, and this is my email. But sometimes it's too many in my email, so I mislook. Okay.
Got it. Thank you.
Okay, so maybe you can introduce yourself if you WhatsApp me, okay?
Yeah, I will.
Okay, is it
Okay.
possible to click for that link? Can you directly go to WhatsApp?
Maybe not. I can send email to you.
Okay.
Okay, thank you.
My phone number, this is Malaysia number. And also you can ask for help from Dr. Rohaya, okay? She's in charge on the measurement and evaluation. Okay, so maybe she can help also.
So, how can we get in touch with her too?
You can ask a supervisor for that. And she will give the numbers because she in charge for the measurement and evaluation for all students. Okay, so you can ask your supervisor for her number.
Okay, may I have the name again, please?
Dr. Rohaya.
Dr. Rohaya. Okay.
Okay, how about the rest? All good. It's already 10:54. Okay, the time is too short for us. Okay, let me share one by one. This is screen share. Okay, the first one, this is the, let me see on here. So the first one is quantitative data analysis guides. So this is the one. Okay, so this is the guides how to use the SPSS. Okay, you can always use this. Okay, this is actually previously for my students for statistics. Okay, so you can always use this. Hope this helps. Okay. And then the second one is example of quantitative data analysis writing. We will see later about this. And then example of questionnaire. Okay, this is the questionnaire. We do something quick. Okay. This is an example of questionnaire. Okay, wait, change questionnaire. Just forget. Just don't care about this. Okay. So first one. Okay, for this question, in what age group are you? Okay, look at here. It is about age, but it was ordered. Okay, and has a category for this. So, what do you think the measurement scale for this data? What do you think? Anyone can answer?
Category.
Category, there is no measurement scale for category. Specifically, what is it? There is 4 measurement scale.
It's not nominal.
Okay, it is ordinal. Okay, because you order it. Okay, supposedly age is a ratio. Okay, ratio scale. So when it is ratio scale, you can have mean, mode, median, okay, standard deviation, and so on. However, if you want the data to be like this, okay, it became ordinal. So careful for your data. Okay, basically the age is a ratio, okay, but if you make it ordered like this, it became ordinal. Okay, so please be careful when analyzing your data. Okay, and then gender, what do you think is the measurement scale for gender?
Gender is nominal.
Nominal, yes, correct. Yes, also correct from the chat. Thank you. Okay, and then weight in kilogram. So what? Pardon?
Nominal.
Weight, your weight.
You wait. You wait.
Weight. How it looks like?
Oh, this is interval.
Interval.
Ratio.
Ratio.
Yes, weight is ratio because 0 kilogram means you have not born yet. Okay, you are not in the world yet. Okay, so it has 0 kilogram of weight because you can compare. Okay, 0 kilogram and certain kilogram. So weight is ratio. Okay. And then from the following, which is the closest to your current occupation. So what is the measurement scale for this?
Nominal.
Nominal, yes, correct. And also this one is nominal. Okay, that's good. So for this one, this is called Likert scale. Likert or Likert scale. So you order it. Strongly disagree, disagree, agree, strongly agree. So what is the measurement scale for this?
This is ordinary.
Ordinal, yes, correct. Ordinal. Okay, so I know most of you use Likert scale. Okay, so if you are using the Likert scale, it is ordinal scale. So it's supposed not have mean, no standard deviation. Okay, it can has median, it can has mode. You can find the frequency. Okay, so please bear in mind for this. Okay, yes, I know when you find online or anywhere, you will find that they use the mean. Okay, they will calculate the mean, but if you are really following the statistics, so please follow the statistic correctly. Okay, I hope that. So, and then okay, I skip on the example of quantitative. Okay, so for the quantitative, this is the writing, example of writing. Okay, this is just an example. How to write your chapter 4 or 5. It depends whether it is in your chapter 4 or in chapter 5. Normally for educational technology, it is in chapter 5. But if you doesn't develop anything, then it will be in chapter 4. Okay, it's about results and finding. Okay, so how to write your chapter 4 or 5 for results and finding. Okay, the first one, of course, 4.1 or 5.1 is the introduction. Okay, and then 4.2 or 5.2 is the findings of the first research question. Okay, I know when you have questionnaire, let's say you have questionnaire, you will tend to explain all in your questionnaire. How many male, how many female, how many all of all the thing, the demographic data. But in your research, there is no research questions about demographic data. Okay, so it is not suitable. Okay, so please for your chapter 4 or 5, the results and findings, the point 2 must be about the findings of your first research question. Okay, understand that? Okay, let's say this is the first. So this section will address the first of research question. What is it? Okay, so what it requires? Okay, what have you done? Okay, what have you done to answer the first research question? So explain it here. So then what have you done and then what have you got? This is the data of what have you got from the for the first research question. This is just a raw data. Okay, let's say this one to compare pre and post. So you have this table. Okay, you cannot write their name here. So you just use the identity. Okay. Oh, it's already 11:02. Is it okay? Can we continue?
Doctor.
Yes, doctor,
Okay,
please.
sorry to take longer than 1 hour. Okay, so since the data is ratio, okay, so you can calculate the mean. If the data is not ratio or interval, you cannot calculate the mean. Okay, you can calculate this one manually. Okay, and then you explain about this. So how to perform the statistical test. Okay, so however, if you want to run the parametric test, okay, you must make sure that the data is normal. Okay, so you must run the normality test. Okay, so you have to run the normality test first. So you must have hypothesis. Okay, this is how example of how you write for your result. Okay, you can follow or you can change it. It's okay. So as long as you know how to explain everything, and this is the step by step what to explain. Okay, and then you have to run the normality test. Okay, from SPSS you will get this table. Okay, how you get this table I'll show later. And then if you want to compare both, you must make sure that both variables are normal. Okay, so you will see on this significant value. To ensure that it is normal, so the significant value must be greater. Okay, it's not like a parametric test. Okay, for parametric test, you must make sure that the significant value is less than 0.05. Okay, because look at hypothesis. Okay, look at hypothesis. So look at, there is above and below, null, alternative. For null, the population is normally distributed. The alternative is population is not normally distributed. So we can say that this one is above, this one is below. So you can also compare to 0.05, the alpha level. Okay, so when you want to compare the 0.05, is it above or less? If it is above, then it's normal. For this example, it is less. So it is not normal. The pretest not normal. Understand?
Yes.
Okay. And then, so same goes for post-test. You see here, it's greater or less. Since it is less than 0.05, look at the below one. then it is not normal also. If one of these not normal or both not normal, then you have to run the non-parametric test. This is how to write. Okay, this is how to write that you cannot run. This is how you cannot run the parametric, so you run the non-parametric alternative. Okay, this is how to write in your thesis. Okay, and then there is two hypotheses. Okay, no significant difference, and there is a significant difference. Okay, so you will get this table, okay, this table, and then you explain. So same goes here. To compare, you will see the asymptotic significance here, 0.000. So you compare with the hypothesis. Same like above one. Okay, if less than is above or below, above, below. If above or greater than 0.05, then no significant difference. If less than 0.05, then it is below, then it has significant difference. That's how you interpret. Okay, I hope you can understand on this. That's why you must have null hypothesis, so you will not do mistake for this. When you have hypothesis, you can compare to the hypothesis. All right, so now let's go to SPSS. Okay, I gave you the SPSS file to try, but if you don't have the SPSS, it's okay, you can try later, follows this video. Okay, do we have time for SPSS? Can we proceed?
Yeah.
Is it okay? All right, so in SPSS, okay, here this is example, you have gender, race, okay, this is the variable view, this is the data view. You can see below, data variable. Okay, you can use you can open yours. Okay, so here the name must be only one word. Okay, only one word. And then the type, the decimal, you want the decimal or not? Okay, let's say here the name is test1, but you want to label it. This one can use more than one word. Okay, let's say test June. You want to write it. So this one is test July. This one is test August. So you want to compare between the test in 3 different months. Okay, so if you write something in the label, then your SPSS result will follow this label. If there is none in the label, so it will follow the variable names. Okay, so for gender, okay, because gender you have here values, 2 options, so you can use number. 1 is for male, 2 is for female, or vice versa. Okay, just put it value here and put it label and add. Okay, same goes to race. Okay, value here, label here, add, and so on. Okay, so the measurement scale here you can change. Okay, this is fast data input. So for example, if the data is ordinal, nominal, scale is for interval and ratio. SPSS use only one measurement scale, which is scale. Scale is actually interval and ratio. So the rest is ordinal, nominal. Okay, you can change yourself. Okay, and then the data. This is the data view. This one because I choose only one decimal, so the data is this way. Okay, and then you can to analyze, it's here, analyze. The first one, the first thing first, because you have, if your data is ratio or interval, you have to run the normality test. So analyze here descriptive statistics. Analyze descriptive statistics, explore. Okay, analyze descriptive statistics, explore. Okay, so gender cannot, it's not a ratio or the interval. Okay, test, you can run the test, you can run all test. Okay, you can press the shift button on your keyboard if you are using the Windows. Okay, and then bring to the right. So you want to test for these three variables. Okay, and then look at statistics. Okay, it is descriptives. If you want to find the outliers, you can. This is, for example, you have many sample. Okay, a lot of sample. You can find the outliers. So if the data is on the outlier, is an outlier, so you can delete the data because it affects your statistical result. Okay, so for this one, no need. So continue. Plots. Okay, this one you must click on normality plots with test. This is the normality test. Okay, continue. Okay, for options, okay, nothing. And then, okay, that's all. Okay, okay, oh, okay, you will get this. So you will get the valid, missing, total. Okay, no missing, all valid. And so the total is 35. Okay, so this is the descriptives. You can use this also to write on your paper, your thesis. Okay, but for normality test, we only use this. Okay, just copy this table. Okay, like for my example here. Okay, this is the table, but I only use the Shapiro-Wilk. Okay, this one I mentioned it right. This one I mentioned it here. Okay, yes, Bahir, you must install the SPSS program first. So you watch this tutorial first, then later you can try it. Okay. Okay, the first one, I use the Shapiro-Wilk only. Okay, because in the SPSS there is Kolmogorov and Shapiro. So you can adjust the table. You can create the table and then you put in the data. Okay, so this is just like what in the label. Okay, so for example, Kolmogorov is normally for data greater than 1,000, 2,000. Okay, very lots of data. So for us, normally we only use Shapiro-Wilk. So only take the data from this one. Okay, only take here statistics, DF, significant. Okay, degree of freedom. Okay, so just look at here. Okay, for test June. Okay, so remember on this. Above, below. Is above normal, below not normal. Okay, so for June, is it normal or not?
No, normal.
Normal. July?
No, non-normal.
Not normal. Okay, August?
Non-normal.
Not normal. So since there is one or two or all variable is not normal. Yes, I recall. Okay, since one of the variable, at least one of the variable is not normal, so I cannot run the parametric test. Okay, understand?
Yes.
So we have to run the non-parametric test. That's how we use it. Okay, so remember, but if your variables are ordinal and nominal data, no need to run normality test. Of course not normal because they are discrete variable. Discrete variable has no data between two neighboring categories that I said before. So there is no data in the middle. Okay, let's say between blue and red, there is no in the middle. Okay, there is no in the middle between blue and red, between Malaysia and China. There is nothing in the middle. So we cannot, we don't have to run normality test. Of course, it is not normal. Okay, so please bear in mind. Okay, so and then this is for the normality test. And then we have here one sample t-test. Okay, compare means one sample t-test is here. Independent sample t-test. One sample t-test is actually you have one sample. And then you want to compare the mean for that sample with the mean of population. Okay, that's for one sample. And then if independent sample, it means the samples are independent. Okay, T is for two, T. Okay, when you have junction, T junction, you must choose left or right. So it's compared two groups only. Okay, so for independence, it means both samples are independent. Okay, from two different class or from two different genders, from two different race or two different whatever lah. Okay, so you want to compare your data. And then packed sample t-test means only one group, but you test them twice. For example, pre-test, post-test. You test them twice. Okay, pre-test and post-test towards the same sample. It for packed sample t-test. Okay, and then one-way ANOVA. Okay, so for one-way ANOVA, it's for more than two independent samples. It's like this one, independent sample t-test. T-test for two. One-way ANOVA is for more than two. For three groups, three different groups, four different groups, five different groups, and so on. Okay, and then we have here repeated general linear model. Repeated measures. Okay, repeated measures just like packed sample t-test. Packed sample t-test, there is one group, you test twice. Same group, you test before and after. Okay, and then for general linear group, you test more than twice. Maybe you test them thrice, okay, more than 3 times, 4 times, 5 times, and so on. Okay, understand the difference between that? Okay, what about control and experimental group? To compare them, I should use PET t-test. No. Control and experimental group is two different groups, right? So why you use PET? Two different groups. If you want to compare the pre-test for control and experimental, it means they are from different group, two different group, control, experimental. So different, totally different. Control group are different person. Yes, independent. Okay, experimental group, different person. So using the independent t-test. However, if you want to compare pre-test and post-test for control group, okay, for control group, you compare pre-test and post-test. Then you use PET t-test. And then for experimental group, you want to compare their pre-test and post-test. So you also use PET t-test. That's how you do it. You do that, okay?
Okay.
How the relation between A and B vary by. Okay, yeah, this one, if you want to find the relationship A and B vary by C. Okay, for example, the gender, is it? For example, you want to find the relationship between test 1 and test 2 and vary by gender. This is for Zuling privately. Okay, so you can do that by put it into category group. Okay, by comparing in the group. Okay, we'll see later. And then we have here correlate. Okay, correlate by rate. Okay, by rate, this one here, to correlation, there is 3 correlation here. Okay, one Pearson, one Spearman, and point biserial correlation is here, bivariate. Okay. Yes, we will. Yes, I'm record this, and the recording will be on the website. Okay. And then the regression, normally we use the linear regression here. Okay, and then non-parametric test is here. All non-parametric test is here. And also here, cross-step. One is in cross-steps. One is in non-parametric test, legacy dialog. I always use this one, legacy dialog. Okay, the chi-square is here. This is for one sample. Like I said before, you don't have to remember what is the name, as long as you understand what is stated here. One sample is for one sample. Okay. This is the parametric, one sample t-test. The non-parametric is one sample here. Okay. This is 2 independent sample. It means you compare 2 different sample, but non-parametric way. K independent sample means more than 2. 4, 5, 6, 7, 8. Okay. 2 related sample just like the paired t-test. Okay. One group you test twice. And K related sample, okay, means one group, one sample you test more than 2 times. It's here. Okay. Let me show you some of that. The compare means, okay, normally we use the paired sample t-test is here. Okay, you can put it here to compare. Okay, so test June, you want to compare first and last, let's say. This is pre-test, this is post-test, first and last. Okay, and then options, okay, 95%, it is 0.05 alpha level. Continue, that's all. Easy, right? That's all. Then you will get here. So you can write the what it means here. So the standard deviation is here. So from this actually you can explain when your mean is lower than June, has lower mean than August. So you can explain in your thesis. So the mean for August is better, higher. Okay, about the standard deviation, okay, you can explain that the distance between mean and scores are big for June. It means that one standard deviation for June is very big. So it's 70 plus 12. It's 82. Very the distance is very far. And then this is the standard error of mean. And then here is the correlation. Okay, since there is a correlation here, okay, let me share also. You can use this correlation. Okay, so here for correlation, the first one, you have to look at the significant value. Okay, if the significant value is less than 0.05, it means that there is a correlation between both variables. If the significant value is greater than 0.05, like this example, it means there is no correlation. Okay, then you don't have to look at this correlation value, no need. Just mention in your thesis that there is no correlation between the variables. Okay. However, if here is less than 0.05, so you have to look at the correlation here. Okay, the correlation value is from 0 to 1. positive or negative. Okay, it only has 0 to 1. There is no 1.5, 2.5, 7.5. No, there is only from 0 to 1. Okay, if it approaching 1, it means it has a strong correlation. If it is approaching 0, it means it has weak correlation, and 0.5 is in the middle. So it's just medium correlation. Okay, so understand. So for this one is very weak correlation because it's 0.06. Okay, it's even less than 0.1 here. So very weak. Okay, so and then for this one, for PET sample t-test, okay, the first one also look at the significant value. Always look at the significant value first. Okay, and then you will look at the rest. Okay, if here it is less than 0.05, that means there is a significant difference between test June and test August. Okay, so look at here, the mean is negative. Don't worry if the mean is negative because look at here. This is the formula actually. June minus August is negative. It means the June is lower than August. So August is better than June. That's how. Okay?
Okay.
But if you arrange the test here, test August minus test June, you will get the positive value here. This is positive, this will be positive, positive, and positive. That's all. That's only the difference. Okay? No worries about this. Okay, sorry, the T is same. Okay, so and this TF. So here, from here, you have to write this way. Because here Wilcoxon use Z. So for t-test, you have to use T. T equal to negative 8.403. And then you can have DF. DF equal to 34. And P equal to significant here, 0.000. So once the statistician or any academician see this, they can understand, oh, there is a significant difference here. They don't have to read. They can see, oh, there is significant here, and the DF is 34. So that means the total sample is 35 because the sample, the DF for t-test is -1. 35 minus 1 equal to 34. That's how it is. Okay. Yeah, I did it first because this is actually for different one. Okay. So the question, what is the difference between sig and correlation? What do you mean by sig and correlation? Sig here and correlation here? What do you mean, Mingsu?
Doctor.
What do you mean by your question?
Because you said the significance value means if they have the correlation, so I was wondering why there are two here because they are the same. Am I right?
Sig and here, this one and this one, is it?
Yes, it is.
Oh, no, it's not the same. It's different. Significant value to identify whether it has correlation or it has significance or not. There is significant or there is a correlation or not. That's all. But the correlation to identify how strong is the correlation. Is it strong, weak, or medium correlation? Understand?
Okay, thank you, doctor.
All right. So I hope you understand for that. Okay, let's now I show you the correlation. look at here, correlate, bivariate. Okay, you can see the matrix. Okay, let's say I show here 5 variables. Okay, so I want it is Pearson is for parametric, Spearman is for non-parametric. It's easy, it's all here. So whether you want to use Pearson or Spearman, if it is interval or ratio and normal, then it is Pearson. If it is interval, ratio but not normal, it is Spearman. Okay, if it is in ordinal and nominal, then it is Spearman here. That's all. Flag significant correlation, it will help you. Okay, and okay, this is called the matrix correlation matrix, because it is a matrix. Okay, this is the correlation matrix. So all correlation you will get this matrix. When you use the Spearman, Pearson, Phi, Kramer, okay, chi-square, and so on, you will get this matrix. So this is the Pearson. If you want to use the Pearson, the data is here. If you want to use the correlation, so the Spearman row, the data is here. Okay, the difference only like this. For Pearson, you always have to write this way. So this way. So for Pearson, you will write R. R equal to, this is the correlation coefficient. Let's say here there is none, no correlation at all. Okay, I will find the one that has correlation. Correlate by rate. Okay, we want to find, okay, this one, look at here. When there is a correlation, there is a star here. Correlation is significant at the 0.01 level. Okay, so there is star here. So let's say you want to write like this. Okay, this means that the test June and July have a, let's say, correlation. Okay, so the statistical way is like this. R equal to 0.692. 0.692. The significant here is 0.000. It's the same. Okay, 0.000 right here. Okay, so this is to show, the significant is to show that there is a significance between two variables. Okay, because it is less than 0.05, so there is a there is a correlation. And then you want to see the strength of the correlation. So look at here, it's from 0 to 1. So 0.692, some of the studies says that it is strong correlation. Some of them say that this is medium correlation. Whatever it is, please find a reference for that. Okay, so this one, it could be medium correlation. So there is, you can write, there is a medium positive. It's positive because there is no negative here. There is a medium positive correlation between the scores for test of July and June, and the scores for test of June. This is how you write. Okay, so you put it here. That's how to write in your thesis. Okay, it positive means that if their score in June is high, then the result in July also high. So it's positive. Okay, if the score in June is low, then in July also low. That's how, that is positive. If negative, it means if July is high, then in June is high and then in July is low. Okay, it's what we call vice versa lah. Okay, dia bukan vice versa, apa nama dia? Dia terbalik. Apa yang terbalik in English? Sorry, I can't think. Opposite, yes, opposite. So in June, if it is negative here, you must make sure here. If there is negative here, it means if in June is positive, then in July is negative. So it's opposite. Alright. So please understand that. Okay. I hope everything is clear. Okay, and I will share also here. Just look at here. Okay, for two independent sample, this is the non-parametric of independent sample t-test. The name is Mann-Whitney. So like I told you before, no need to remember. It's stated here. The name is Mann-Whitney. Okay, no worries. And then if the parametric for K independent sample, this is for one-way ANOVA. The non-parametric of one-way ANOVA. The name is Kruskal-Wallis. Okay. And then if two related sample, this is the non-parametric of PET t-test. The name is Wilcoxon. Okay. And then lastly, this is for repeated measures ANOVA. The non-parametric of repeated measures ANOVA. The name is Friedman. Okay, that's how to do that. Okay. So I hope everything clear. Okay, for step-by-step to use statistic, maybe we can have next session later. Can we? Because it's too long already. Maybe we can have second series of statistic. Inshallah. If everyone needs it, then I can do that. Okay, just tell Dr. Zack about that. Okay?
Doctor, I have some questions.
Yes.
The first is that when you show the word, there are so many hypotheses, non-hypothesis and alternative hypothesis. Can we only result the test values? For example, the test for the normality, can we omit or cancel the normality test, just show the results, the p-value, the p-value, and not write the non-hypothesis or the alternative hypothesis, just show the p-value, the p-value and the test value. Because there are so many hypotheses.
Okay, you mean that you just want to run the test without any hypothesis written, is it?
Yes.
Okay, so it's possible also, but this one is good for you to have hypothesis. But if you don't want to put it hypothesis, still you can have you can do that. But you must make sure that you make conclusion correctly. Okay.
Okay. Yes, that means we can not write so many hypotheses in the article or the thesis. Just show the results of the test and choose the right method to analyze. Yes.
Okay. By the way, the hypothesis is only in this chapter. Because sometimes there is a requirement that you have to write the hypothesis in the chapter 1, right?
Okay.
But for this one, no need to write the hypothesis in chapter 1, no need. Okay, you just write it here because it helps you to conclude your data.
Okay.
Because let's say like this, okay, for example, you run this one, okay, for example, you run the normality test for pre-test and post-test. But later in next subtopic, you still using the pre-test and post-test. So no need to run again. You just mention that based on table 5.2, the pre-test is not normal. No need to run again and again.
Okay, thank you. The second question is that there are many versions of SPSS. The same data, yes, the same data to run. Are there any differences between the values? Yes, there are so many versions of SPSS.
Okay,
Or we should use the very new version.
The version is actually up to you because I'm using the previous version actually. So it's okay because you will get the same result. No problem.
The same result. Okay.
Yes.
Thank you. The second question is that can we see that ratio scale is ratio scale? For example, the way the height is always a continuous variable. Is that right? Continuous.
Yeah, ratio scale is continuous, but when you collect data in different way, it can be discrete. For example, like I give you example on age. Okay, age is ratio. Age is ratio scale, but if you collect data that way, it became ordinal.
Yes. Yes.
So be careful for that. Okay.
Okay. Thank you.
Okay. So any more question? It's already 11:42. Sorry for your time.
Thank you so much, Doctor. Although I have
Thank you,
more
Doctor.
questions, but I think maybe it's too late.
Okay, I hope it helps you to analyze your quantitative data. And if you have any question, you can always ask me. But maybe I will answer quite late, okay, because I have classes and meetings and so on. But I hope to see you again. Okay, if needs for the specific way how to use the SPSS, maybe we can meet later and you can request from Dr. Zack. Okay.
Okay.
Okay, see you inshallah. Thank you very much. Thank you for listening. Assalamualaikum and good day everyone. Bye-bye.
See you.
Bye-bye.
Bye,
Thank you,
doctor.
doctor.
Thank you.
Thank you.
Thank you so much,
Bye-bye.
doctor.